All right, everyone. Uh, we got two more examples left, and actually these last two examples deal with cubic functions. So we're getting away from quadratics just for a really quick second. They want you to start graphing, and not only graphing, but in the next example, they want you to be able to work backwards. So be able to look at a graph and come up with the function from the graph. So first off, let's just go ahead, let's figure out how can I graph this cubic function. One thing I just want to make you guys aware of is that a cubic function, so a quadratic has just like the U shape to it. A cubic now all of a sudden has an extra little tail to it, I guess you could call. So you're going to have kind of a maximum value and you're going to have a minimum value. So you're going to end up having three different x-intercepts. Okay, so something to look for. Okay, let's go ahead and let's start by looking at this function. So f of x equals x cubed minus 4x. Again, first thing you're going to want to look for, what's the common factor amongst these two terms? Hopefully you're able to recognize that there is an x in each of them. So we're going to start by taking that x out, and that's going to leave you with x squared minus 4. Okay, now from here, what you can do is, again, hopefully you're able to start recognizing that this is a difference of cubes, and I'm going to keep mentioning it because I really want you guys to make sure that you're able to recognize these. F of x equals x. Let's factor this x squared minus 4. Remember, x squared should be x times x. I've got a 4 here. How can I come up with 4? That'd be using 2 and 2. We have no middle term, so they have to have opposing signs. And then the next thing that you can do, you guys, is you can just use the zero product property. We want to figure out where this entire thing is crossing the x-axis. So we're just going to take all three of these terms, we're going to set them equal to 0. So x equals 0, x plus 2 equals 0, x minus 2 equals 0. And we're just going to find the three x-intercepts. We already naturally got one. Here's a second one. And then our third one is x equals 2. All right, so I'm going to go ahead. I am going to graph all these points. So I'm going to start at x equals 0. I've got negative 2. I've got positive 2. Okay, awesome. Now, the main question remains, you guys, is this graph going to go, is it going to be positive, and is it going to look like, are you going to have the minimum on the right side and the maximum on the left side? Is it going to be the opposite direction? So we have to still figure out, like, where is the maximum of this cubic and where is the minimum of this cubic? So in order to find the point or where it's going to go in between these 2 points, pick the point that's in between. Pick negative 1 and plug it back into the function. So figure out f of negative 1. So negative 1 cubed again would just still stay as negative 1. 4 times negative 1 would be positive 4. So you have a point at negative 1, 3. So go ahead, plot that point. Okay, so that gives you just kind of the basic shape. You know that this graph is going to go from this point at negative 2, 0. It's going to go up to this negative 1, 3, and it's going to come back down. But we still have to figure out that minimum right here at 1. So we're just going to do the same process. We're going to figure out f of 1. So then we figure out that it's going to be at negative 3. So we're going to bring this down here. And then here's kind of the way that this graph follows. We're going to start here at this -2, because remember, we always read a graph like we read a book from left to right. So this is going to go up to this maximum point. It's going to come back down through the x-axis, or through the origin, I should say. It's going to come back down and go back up. And it's going to continue. I'm going to continue this one off to the left. So there's the graph of our cubic function. All right. Lastly, so I am going to do the next example with this one because the last one was kind of quick. We're going to do this last example, and then you're going to be expected to do 13, 14, and 15 just kind of on your own. First things first, they give you a graph, and you have to basically come up with the function. So if we kind of start thinking about it, we're given the x-intercepts, 1, 2, 3, we're given 0, 0, 2, 0, and 5, 0. We're going to use intercept form. So we're going to do x minus p, x minus q, and then yes, we do have 3 of them. We have 0, 0, 2, 0, and 5, 0. So we're going to throw a third piece in there where we're just going to do x minus r. So we'll just call that third point r. Let's begin by plugging P, Q, and R in. So I'm going to have P be 0, I'm going to have Q be 2, and R be 5. So maybe I'll just make a note of that really quick. P is going to be 0, Q is going to be 2, and R is going to be 5. So let's just do our substitution really quick. Okay. Now, I'm just going to take a second and I'm going to simplify because the math person in me just likes to see that as x instead of x minus 0. All right, now, hopefully you guys have noticed that with these 3 intercepts that you see, they've also given you a separate 4th point. They've given you another coordinate at x, y. So maybe you guys have already guessed it. We're going to take 3, we're going to plug it in for all of the x's that you see. We're going to take 12 and we're going to plug it in for f of x over here. And we're going to quickly solve for a because that's the only thing we don't know. We just have no idea if there's any stretching or shrinking going on with this graph. So we just need to figure out what that is. We got to figure out, I mean, is this a going to be positive or negative? Like what way is this graph opening? Is it odd, even kind of thing? So then we're going to take, let's see, x is 3. So we're going to plug 3 in for all of the x's here. And now we're just quickly going to go ahead, let's solve for a. So if we just kind of go ahead and simplify, we've got 3, we've got 1, we've got -2. And then let's see, this turns into 3. 3 times -2 would be -6. Solve for a. So then your a would be -2. All right, now we're able to put all of the pieces together. So here's our new function. So we've got f of x. Your a value is -2. And then you will be able to, let's see, let's do that as x. And then we can do x minus 2. And then we can do x minus 5. And then I believe just kind of looking through your book and what it's asking for, I believe it's going to take this and it's going to want it in standard form. So let's just take this to the next step. So this right here would be x squared minus 7x plus 10. So then we would end up with negative 2x cubed, because remember it's a cubic function. You can remember this, that there's 3 x-intercepts up here on the left. So your exponent should be x cubed. So that's going to be negative 2x cubed. You're going to end up with positive 14x here, and then negative 20x. And there is that final function. All right, so you guys go ahead, try 13, 14, and 15 on your own. I will see you guys tomorrow, and we can go through any questions or concerns that you guys have. I hope you're having an awesome rest of your day.